Let's look at problem-solving strategies. Write an equation. There was an ancient Greek mathematician named Diophantus. A riddle written in the 5th century explains how old he was when he died. Here's a translation of this Greek riddle, supposedly written on his tombstone. Here lies Diophantus, the wonder behold. Through art algebraic, the stone tells how old. God gave him his boyhood, 1/6 of his life. 1/12 more his youth, while whiskers grew rife. And then yet 1/7 ere marriage begun. In 5 years there came a bouncing new son. Alas, the dear child of master and sage met fate at just half his dad's final age. 4 years yet, his studies gave solace from grief. Then leaving scenes earthly, he too found relief. How old was he, Diophantus, when he died? One problem-solving strategy is to write an equation. Well, how do you take this riddle and write an equation? Ask yourself what you want to know, and if necessary, choose variables appropriately. State what each variable represents. That's another problem-solving strategy. So in this case, what do we want to know? Ultimately, we want to know how old Diophantus was when he died. So that's how we choose x. Let x equal the age of Diophantus when he died. This riddle enables us to come up with an equation for Diophantus's age when he died. So again, boyhood was 1/6 of his life. If his total life was x, then 1/6 of x is his boyhood. Add to that a 1/12 of his life. In other words, 1/12 x. Add to that 1/7 more before marriage begun. So he spends 1/7 of his life after youth waiting for marriage. And then after that, 5 years more and comes a son. So far, he has spent 1/6 of his life, a 1/12 of his life, a 1/7 of his life, and now 5 years. And then his son only lives for half of his dad's final age. So we have half of Diophantus's life. And then after that, Diophantus dies 4 years later, 4 years after his son dies. When we add these together, 1/6 of his life, which is boyhood, a 1/12 of his life, which is youth, a 1/7 of his life, waiting to get married, 5 more years, half his life, that's the time his son is alive, and then 4 more years. When we add all of those together, we get his total life, which is x. So let's take this equation. How on earth do we add these together? Well, we remember how to add fractions. We find a least common denominator. What's the smallest positive integer which is divisible by 6, 12, 7, and 2? That'll be our least common denominator. Well, if it's divisible by 12, then it's also divisible by 6 and 2. So we can simplify it. Really, when you say what's the smallest positive integer which is divisible by 6, 12, 7, and 2, you're really saying what's the smallest positive integer which is divisible by 12 and 7. Because if 12 divides it, then 6 and 2 also divide it. Turns out that's 84, which is 12 times 7, because 12 and 7 don't have any common factors. So here's our equation. Let's express everything with denominator 84. So we need to multiply top and bottom of the first fraction by 14, because 6 times 14 is 84. Top and bottom of the second fraction by 7, because 12 times 7 is 84. Top and bottom of the next fraction by 12. And then lastly, top and bottom of the next fraction by 42, because 2 times 42 is 84. So we have 14 84ths plus 7 84ths plus 12 84ths plus 5 plus 42 84ths plus 4 equals x. Now that we've got common denominators, it's relatively easy to add fractions together. Again, all of those coefficients of x, 14 84ths, 7 84ths, 12 84ths, 42 84ths, we can add all of those together. And then we also have a 5 and a 4. So here's our equation now. Recall that if fractions have a common denominator, when you add them together, you can just add the numerators. So when you add all of those together, 14 plus 7 plus 12 plus 42, and then, of course, 5 plus 4 is 9, here's what you get. 14 plus 7 plus 12 plus 42 is 75. So we have 75 84ths x plus 9 equals x. Let's get the x's on one side. So moving the 75 84ths x to the other side, we have x minus 75 84ths x. And here's how we'd go about calculating that. We can factor out the x from that. So x minus 75/84 x, that's like 1 minus 75/84 x. When we factor out the x. And 1 minus 75/84, let's write 1 as 84 over 84 so that we have a common denominator. And now that we have a common denominator, we can subtract these fractions just by subtracting numerators. 84 minus 75 is 9. So we have 9 equals 9/84 x. 9 equals 9/84 x. So we're going to divide both sides by 9 over 84 so we get the x all by itself. 9 divided by 9 over 84 equals 9/84 x. Divided by 9/84, those 9/84ths cancel, and we're left with, well, this is what we have. After the 9/84ths cancel, we're left with x equals that left side. How do you get that left side? Recall that dividing by a fraction, like 9/84ths, is the same thing as multiplying by the reciprocal. So dividing by 9 over 84 is the same thing as multiplying by 84 over 9. And the 9's cancel, and we're left with x equals 84. Now, again, one problem-solving strategy. When you're solving a math problem, don't write x equals 84 as the solution. Instead, express your solution. Once you have an answer, state the answer in terms of the original problem. In this case, we wanted to know how old Diophantus was when he died, so Diophantus died at the age of 84.